Yeah, so good afternoon, viewers. So back to business. So this is part 2 of the wheatstone bridge. We continue from where we ended. So now we calculate the current flowing at the point C, D, B, A, B, C, A, C, A, D, and also B, D. So how can we calculate this? So for us to calculate the current flowing at the points C, D, so we say current flowing at the point C, D equals the total current times here is the secret which is there. If you are finding the current at point CD, you don't have to get this, you don't get this resistor which is the 14 ohms resistor, but get the opposite resistor which is the 2 over there. So this becomes 12 over 12 plus 14. So what is the current total? The current total we found in the previous video, it was 10 points. It was 10.178 times. So what about we deal with this situation? 12 plus 14 is 26. So 12 divided by 26, I'm getting 0.46153. Confirm there. So we come to the curve, we compute current CD. So we multiply that by 10.178 as the total current. So this gives us 4.6975 like that. Yeah. So we come to, this is our current of CDEA. So now we come to the current flowing at the point EA. Since we have gotten the concept, so we just go direct. So the current total EA, the current total, so we get is 10.178 amps times, since we are finding the current flowing at the point BA, so we get the opposite resistor, which is the 16 there. So 16 over 16 plus 8. So there we say 16 plus 8, that's 24. So we say 16 divided by 24, that's 0.66. So there I'll have 10.178 times 0.6666. So the current flowing at the point BA, the current flowing at the point BA, so I'll multiply with 10.178. So this gives me 6.785 amps. Like that. So now let me just write here. So current at the point CD, we have this 4.698 like that, or you can see here like that amps. You can now go from there. Then current at the point BA, the branch BA is 6.785 amps. So I can create some space so that it calculates the main currents. So now we come to the current flowing at the point BC. So we know as our method the total current, multiply the total current, which is 10.178 amps times, since we are calculating for BC, so where is our BC? It's here. So we won't get this 16 ohms, but we get the opposite resistor, which is 8 ohms. So we say 8 over 8 plus 16. So this becomes 10.178 times, so 8 plus 16, that's 24. So 8 divided by 24, that gives us 0.33. keep going like that. So current at BC, so we multiply times 10.178. So this gives us 3.3926 like that. So amps. So I don't want to round up the answers, but we can just leave them like that because we need to calculate the final solution. So we come to the current of point AC. So this first, we calculate the current of AD. So I want to explain by AC. So first, we come to AD first. We calculate the current flowing at point AD. So current flowing at point AD is equal to the total current is the formula, which is 10.178 amps times, since we are calculating for AD, we get the opposite resistor, which is 14. So that's the circuit which is there. 14 plus 12. So this becomes 10.178 times. So 14 plus 12 automatically that gives us 26. So 14 divided by 26. So that's 0.538 like that. So the current flowing at the point AD. So AD, you multiply that with 10.178. So this gives us 5.480 amps. So now, since we have these currents, we can now calculate the current flowing at this point AC. So we do this current flowing at the point AD, we have found is 5.480 amps. The current flowing at the point BC, we have is 3.3926 amps. So now we can calculate the current flowing at the point AC as well as BD. So what is the current flowing at the point AC? So remember to calculate the current flowing at the point AC here. AC, the current flowing at that point. You need to have the current flowing at the point BA as well as AD. That's when you can calculate the current flowing at this point AC. So now, the current flowing at the point AC, you subtract the current flowing at the point BA. So this current, you say the current flowing at the point BA minus current flowing at the point AD. So what is the current flowing at the point AD? BA. So BA we have is this 6.785 amps minus the current flowing at the point AD is this 5.480 amps. So we can subtract this. So we subtract 6.785 minus 5.480. So this gives us 1.305 amps. So this is the current flowing at this branch AC. So now how can we calculate the current flowing at the point BD? This current here. So the current flowing at point BD is the total current of the circuit. So the total current of the circuit is this 10.178. This is the current flowing at the point BD as well. So you just get it, you light it, you say 10.17 amps. So this is the total current of the circuit, which is the BET. So whenever you see a question like this is how you need to solve this question. So as you can see, we have calculated the current at the point BA, BC, AD, as well as BT. So, like what I'm trying to explain here is that when a circuit is in parallel, the current is different while the voltage is the same. So as you can see, the currents are different. So at each branch, the current we have calculated is different, but the voltage we have is the same. So this is how we calculate the currents for the wheatstone bridge, which is unbalanced. So thank you for watching this video. See you in the next video.